again, this is kind of an interesting one. It's like all of the rest of these are fairly predictable. This one is not as predictable. I mean, if you just kind of look at the rule, it's saying that you cross two vectors and then cross it with a third. It's equivalent to the dot product of these two. And remember, when you find a dot product, what kind of entity do you have?
Scalar.
You have a scalar. So this is a number multiplying vector b. And then minus the dot product of these two, which again gives you a number, times vector c. So this is still a vector because you're taking a vector minus another vector. So that's probably a good one to investigate because it looks a little bit different. So again, just to kind of save time, this is our u cross, I'm using that for u cross b, and again, it was -2, -6, -16, so that's my u cross b, and we crossed it with w, didn't we? Or no, did we? I don't think we crossed that with w in any of the examples that we did yet. So let's do that. Okay, so u cross b is -2, -6, -16. W is 5, 9, -4. Okay, so I'm crossing W with U cross B. -144 plus 24, but then you subtract. So there's my I. And then -80 -80 plus 8, but I subtract. And then -54. Yes, Robert, what?
Minus 30.
5 times 6 is 30.
Yeah, sorry. I guess I was looking at the 9.
Sometimes.
Okay, so we got -30, and then -18, but I'm subtracting, so it would be plus 18. So we get -168 plus 88 minus 12. So this was W crossing U cross B is what that was. Now we're going to dot W and U, and then multiply that through B, and then we're going to dot W and B, and multiply that by U. Okay, so I mean, I found this, I'm trying to test this rule. Okay, so we did, with the vectors up above, we did U cross B and then crossed it with W. We're going to now follow this to see if we do end up with the same thing. If instead of using numbers, you stuck with variables, you probably kind of see the algebra on why. It's just those kinds of proofs can get a little bit messy. Okay, so W dotted with U is going to give me 5 plus 45 plus 8. So that would be 13 plus 45 is 55, 58. And then I think while I'm dotting, I'm going to dot W with V. Okay, because I'm doing this right here. And W dotted with V is going to give me 15 minus 9 plus 0. So that will be 6. So then 58 times vector B, okay, because W is like my A, U is like my C, so B is like the B. So 3 minus 1, 0, and then minus 6, multiplying C and W, U, so W, E. I'm gonna multiply by U.
I think you actually have those two backwards, because you've got W's your A, but like, U is like your B, so you've got your
Oh,
W,
yeah,
U
you're
up
right.
front. Just
Yeah, you're right.
swap their places. I put a minus on the 58 and a plus on the 6.
Yeah, but I'll read that, okay, so hang on. Yeah, so W, okay. So this is my W. This is my E. This is my U. This is the W. This is the U. And that's the B. Okay, so W dot B is this. So 6 should multiply U, so 1, 5, negative 2. And then minus W dot U, which was 58, will be 3 minus 1, 0. So 6, 30, minus 12, 150 plus 24 is 174.
Does that look right?
Okay, yeah, okay, so negative 168 and negative 58 plus, plus, so that will end up being 88 and then negative 12. So what we got over here? Okay. So again, our vectors were pretty random. Again, proving something with numbers is really not a true proof, because it could have just been a fluke that it worked with these vectors, but you pick random enough vectors, if it works out, it's kind of proof enough. All right, so basically, you need to be aware that these rules exist. Again, they do come up in some physics applications. They come up more when you get a little deeper into linear algebra. Actually, an introductory linear algebra class like the one we have here, they usually don't come up. It's kind of like the next tier. Like there's some statistics classes where you use a lot of matrices and linear algebra and statistics classes, and kind of when you get into those type of classes, you more likely run into trying to simplify the work you're doing with your vectors by relying on these rules. But again, we should be aware that they exist, and for the most part, they're somewhat logical. Number 6 is, doesn't jump out as completely logical until you kind of work one out and you see that it works. Okay, so that was just one thing I kind of wanted to make people aware.